Okay, so this is 8.1b about rational exponents, and another name for rational exponents is fractional exponents. Now, this is definitely new. You have not talked about this in Algebra 1, so we're going to kind of slow it down. So you might have a fraction that's just 1 over a number. So an example might be x to the 1/2, x to the 1/3, something like that. And basically the denominator, whatever that number is on the denominator, tells you the root. So this represents the nth root of x. So if it's a 1/2, it would be the square root of x. If it's a 1/3, it would be the cube root of x. If it had been an x to the 1/4, it would be the fourth root of x. Okay? So if you look down at number 1, if I have 25 to the 1/2, that means the square root of 25. And then, of course, you can simplify that to be 5. Or if you look at number 2, because it's to the 1/3, that means the cube root of 7. And in this case, you can't simplify that, right? Because 7 is not a perfect cube, so you'd have to leave it. But the whole point is, if you have a fractional exponent, it turns into a root. All right. Well, what if the numerator is not just a 1, right? So the first example is if it's like a 1 over 2, 1 over 3, 1 over 4. But what if it's like a fraction, 2 over 3? Maybe it's x to the 2 over 3. Maybe it's x to the 3 over 4. Maybe it's x to the 5 over 2. Any fraction, okay? Well, the denominator is still the root, so this is still the nth root, and then the numerator stays as an exponent, so of x to the m. You know, it looks strange, so let me show you. Okay, on number 3, you get a fractional exponent. The denominator is 3, so that means the cube root, and then that 2 stays as an exponent, so you would just say 8 squared. Now I'll simplify that now. It doesn't matter what I do first. I could do the cube root of 8 or I could do 8 squared. My suggestion is to always do the root part first, just because you have smaller numbers to work with. So what is the cube root of 8? Well, look over here. Remember when we said, hey, you really need to know these? If 2 cubed is 8, that's the same as saying that the cube root of 8 is 2. So when we say know the cubes, that means really you also know cube roots. So for example, the cube root of 64 is 4, or the cube root of 27 is 3. See how that works? Or the cube root of 125 is 5, and I guess I could say the cube root of 1 is 1. So when we say to know these, you got to know them both directions. So when I go back to number 3, so the cube root of 8 is 2, and then 2 squared is 4. We'll go to 4 and 5 in a minute, but skip down to number 6. So this time the denominator is 2, so that would be the square root, and then the 3 is your numerator, so it's 9 to the 3rd. Again, like I said, do the root part first. So the square root of 9 is 3, and then 3 to the 3rd power is 27. Okay, skip down to number 8, number 8. So the 2/3, the denominator is 3, so it's the cube root, and then the 2 is the numerator, so 125 squared. Do the root part first. So the cube root of 125 is 5, and then if I square that, I get 25. Okay, so why did I skip these? Well, I just wanted to talk about these separately. If it's a negative exponent, like we learned, or I reminded you in 8.1a, all the negative exponent means is move it to the denominator. So I've got this 9 to the 1/2 in the denominator. Well, we just said 1/2 means square root, so I've really got a square root of 9 in the denominator, and that simplifies to be 1/3. Okay, skip down to number 7. That negative exponent just means put it in the denominator, so 1 over 9 to the 3/2. But like we said, the 2 means square root, and the 3 is going to be a 9 cubed. And so if I simplify, it's 1 over, the square root of 9 is 3. 3 to the 3rd is 27. Look down at number 9. So really this is 1 over 125 to the 2/3. And if you think about it, we already simplified 125 to the 2/3. We said it was 25. So this is just 1 over 25. All right, now I choose number 5 to do last because I don't want you to get confused with a negative out in front here compared to the negative in the exponent. All right, it's the negative in the exponent that moves it to the denominator. A number out in front, a negative out in front does not move it to the denominator. So what I actually have here is the cube root of 64, of negative 64. Cube root of negative 64. And it's okay to take the cube root of a negative number. That's not imaginary. Cube root of negative 64 is just negative 4. Kind of a little note to keep in mind. It's not okay to do the square root of a negative. Remember when we talked about imaginary numbers and we said that that negative comes out as an I? So this would be like 8i. We're not doing this stuff in this chapter. We're not doing imaginary numbers. So you can't take the square root of a negative, but you can take the cube root of a negative. So on these, I would suggest that instead of trying to match them, because it can be very confusing if you try and match them, forget about this side and let's just look at this left side. Okay, we want to write these in terms of a radical, meaning a root. So on number 1, notice because of the parenthesis, that 1/3 is applying to the whole thing. So it's the cube root of the whole thing. Okay, now compare that with number 2. Notice the negative 3x is not in parentheses. So the 1/3 only applies to the x. So the negative 3 is here, and the cube root is only for the x. Okay, so on number 3, because it's a negative exponent, I'm going to put the whole thing in the denominator. And then because the 1/3 applies to the whole parenthesis, that means it's the entire negative 3x that is under the cube root. Okay, on number 4, the negative 3 does not have an exponent, so it stays where it is. But because the x has a negative exponent, I'm going to move it to the denominator. And because it's a 1/3, I'm going to write it as cube root of x. Number 5, the 1/3 applies to the whole thing, so it's the cube root of 3x. Number 6, notice the negative exponent only applies to the x. So the 3 stays on top, and then you've got this x to the 1/3 on bottom, but doesn't that mean cube root of x? So it's all about, what does the exponent apply to? Just the x or the whole thing? So on number 7, the exponent applies to the whole thing, so the whole thing goes to the denominator because of the negative, and then the exponent of 1/3 means cube root. And then number 8, the 1/3 only goes on the x, so the 3 is just a number out in front, and then you have the cube root of x. So they all look very similar, but they're very different. You have to decide, does the exponent apply to the whole thing or just to the x? Okay, and then your homework starts on page 57.